Next, other objects in the universe. We're going to look at stars, singular and binary, constellations, stellar clusters, and nebulae. Binary stars. These are systems of two stars that orbit their common center of mass. Most of the stars in the night sky are actually binary stars. If we're able to observe the period and we know the brightness, we can work out the masses of stars, which is very useful. We need to look at three types of stars. There are visual binaries, eclipsing binaries, and spectroscopic binaries. And here's a picture of a visual binary. How do we know it's a visual binary? Because we see the two stars. This is one of the stars, and this is the other one. So you can see these stars as two separate stars with a telescope. So they're called visual binary stars. And you can see them orbiting, and therefore you can work out the time period for the orbit. And then you can work out their masses if you know the luminosities. Other kinds of binary stars, eclipsing binary. This is where the stars are so far that you can't actually see them as binary stars, but what happens is that one star will pass in front of the other if it's on the right axis, and then the brightness will change because part of the other star has been obscured. So here, for example, we have a very bright white star which is obscured by a dimmer yellow star, so the intensity of the light from that star will go down quite a lot. Here we get the intensity goes down a little bit because the dimmer star is obscured by the brighter star. When the stars are beside each other, that's when we get the maximum intensity because we get the light from both stars. Then we have spectroscopic binary stars. This is where you get blue shift or red shift depending on whether the star is approaching us, which is blue shift, or going away from us, which is red shift. Now, red shift means that the wavelength will be getting slightly longer, which means that the star is moving away from us, and if the wavelength gets slightly shorter, it means it's moving towards us. And this shift of wavelength divided by the original wavelength gives us the shift. And that shift will give us an idea of the velocity. Constellations. Constellations are groups of stars which from our point of view appear to be close together, but they're not necessarily close together. For example, this is a constellation in the night sky, in the winter night sky, of Orion. It looks like these stars are very close together, but they're not. Here's an example. We've got the Southern Cross. From our view, we see this cross here, but the stars are actually very far away from each other. A stellar cluster, however, are stars that are so close together they're gravitationally bound to each other, so they would have an effect on each other due to gravity, such as these, which are globular clusters, and this, which is an open cluster. So a globular cluster have this appearance. You have many stars which all seem to be the same. They have the same age, and these globular clusters exist outside the axes of outside the plane of the galaxy. An open cluster. These are also gravitationally bound because they're physically close to each other, and this is basically a stellar nursery. It's a birthplace for stars. And these exist typically inside the galactic disk. Nebula. Now, these were originally called planetary nebula because when they saw them with their telescopes, they looked like disks, like planets. And actually, the remains of stars that have died, the stars have either basically had a graceful old age, and the outside of the star just drifts into space, so it's a very kind of symmetrical shape. And this is called a planetary nebula. However, if you get a very large star, it becomes a supernova and gets ripped apart, and then you get a diffuse nebula. Here we have an example of a planetary nebula where it's fairly symmetrical. Here's another one which is very nice. Notice there's a tiny star there. This is what's left of the star, and it still radiates enough energy to be able to excite the gases here, so the gases here are still able to re-radiate, the radiation that comes from this star. This had a bit more of a dramatic ending. 900 years ago, the Chinese discovered a star that it was so bright that even during the daytime they saw this star. But then it went away, and they didn't know what it was. And then some years later, we look into the sky and we were able to see that there's this fantastic nebula called the Crab Nebula. And we look at photographs of this Crab Nebula over the last 100 years or so. That's when we started taking photos of it, and we realized that these old photos, the Crab Nebula was almost 10% smaller than it is today. And if you work backwards, you find out that this Crab Nebula actually was created at the time when this other star that the Chinese observed was so bright. And we now know that that was a supernova. The star was ripped apart because it was such a massive star, and this is what's left. This Crab Nebula will now become the birthplace of many newer stars. This is a nebula many years after the star has died, and this will also be the birthplace of stars.